on page 20. Ooh, goodness. I really hate when I do that. 26 when we're done. So yesterday we looked at vertical asymptotes, right? And if we're approaching a vertical asymptote, we're either going to positive or negative infinity, right? Today we're looking at horizontal asymptotes. So that is end behavior, one of the things that we started the school year with. We didn't talk about it in formal limit notation, but we circled back to it at the end of the year, after we already talked about rationals and whatnot. So here's 3 little things we'll talk about, and then we'll come down here and fill this in and talk about it. So if the degree of the numerator is bigger, that means that it is top heavy, like that's kind of how we talked about it, right? Makes it top heavy. Then one thing that we learned with rationals, well, we really learned it in Algebra 2, but then we talked about it again in pre-cal. Then it's top heavy. It has no horizontal asymptote, okay? The limit as x approaches positive and negative infinity then means that I'm actually going to infinity because I don't have an asymptote. If I have an asymptote, that's what I'm approaching. If I don't have one, then I'm going to positive or negative infinity. Make sense? Right? And that is because when the numerator is bigger, that's because the numerator is increasing at a faster rate than the denominator. Okay? So if I have 2 things and we want to think about substituting stuff in, substituting in infinity, but you never actually substitute infinity in. If you show work like that, that's bad, and they're not going to look at anything else you did. But if you think about, if you have a fraction and your numerator is growing much faster than your denominator, and it grows to really, really fast, then the denominator almost becomes irrelevant, right? So even if I just have, x over, x to the 4th over x, that x to the 4th is going to go really fast. Yes, I'm dividing by x, really just becomes x cubed, but we're heading to infinity. Make sense? So no horizontal asymptote. We have to go to positive or negative infinity because the asymptote is what stops us from doing that otherwise. We good on that? Okay. So then, if it is bigger, if the denominator is bigger, that's what makes it bottom heavy. And kudos to y'all for at least remembering that it meant something. Okay, so that's when we were like, okay, well, let's figure out what that means, right? And I know some of y'all, I didn't realize it actually said it up here, but if it's bottom heavy, if I have x over x cubed, or whatever else, other things, if the denominator is growing at a much faster rate, the denominator getting bigger and bigger and bigger makes the overall fraction get smaller and smaller and smaller, right? So small that it's approaching 0, but we never actually make it there. That's why we have a y equals 0 asymptote, and that's why the limit, as we're going out to infinity, we're approaching 0 either from the top or the bottom, but we're approaching 0 either way. Make sense? Okay. And then if the degree is the same, oh, wait. And then the reason is because the opposite of the other one. The denominator is increasing at a faster rate than the numerator. And I'm going to put numer period because I ran out of room, and it's fine. We're not actually explaining, so it's okay. Then we know if they're the same, we consider that tied in degree. And that one usually you remember. Top heavy, bottom heavy, you're like, oh, one of them was y equals 0, but I don't remember which one. Tied in degree, you usually remember that it's the ratio of the leading coefficients, no big deal. And that's because the numerator and denominator are increasing at the same rate. Or, yeah, increasing at the same rate. I'll say or decreasing. So numerator, we'll put numer and denom increasing at same rate. Okay. So Lots of great discussion on how to figure these out before we really solidified it. So now I'm going to make all this much easier. Now, one thing you have to pay attention to is not only just that it's a limit and you have this and we can think top heavy, bottom heavy, no matter what, but these only work when it's approaching infinity. If it's approaching 5, that's a totally different thing, right? We don't care about top heavy, bottom heavy then, right? And that's a trap you can fall into, like, oh, that one's top heavy, bottom heavy, and then that one we really don't care because it's asked differently. So be very careful with that. It's one of those where you're just rocking along and doing the same type of thing, and then bam, it comes out and hits you here. So all we really have to look at, that 50 and 85, kind of irrelevant. I look at the leading two terms. That makes this top heavy, bottom heavy, tied in degree. Which one? Bottom heavy. So we have a horizontal asymptote. Beautiful with y'all, drawing it out. Not that you necessarily have to, but I think it helps because you're here and it's like, okay, I have no idea what the graph actually looks like and I don't care. But in behavior-wise, I'm going to be approaching somehow 0, either from the top or the bottom or whatever, right? But what I really care about is the end stuff, and I am approaching 0, so my answer is 0. And yes, it's really that easy, okay? If this was approaching 5 or something, I might have to factor, or whatever would give me 0. But infinities, you're thinking about them as rationals. All right, so then this one here, we look at these. This is tied in degree. So my horizontal asymptote is at 4/5, which means that that's where my y value is approaching, either from bottom or top. We'll worry about which way later if it matters to us. So my answer is just 4/5. Your answer basically is, what is the equation? What is the asymptote, or where is the asymptote? So on this one, is this top heavy, bottom heavy, or tied in degree? Tied in degree, because you're looking at x times x is x squared, x times x is x squared, right? Now, some of you multiplied the entire thing out, which is fine and beautiful that you're not afraid to do that. Do I really care about the entire equation? I really don't, so I don't have to. I can just look at 3x times negative x is negative 3x squared, and x times x is x squared. So it's really just negative 3/1. So my answer is negative 3. Nothing wrong with multiplying the whole thing out. This is one of the I told you so type of things. Yeah, it's all good. Feels good when you can do that, right? But it's fine if you multiplied it all out. Totally fine. Okay. Now let's look at D. Top heavy, bottom heavy, or tied in degree? Okay. It's top heavy, right? So it's not always the first two I look at, but the two with the highest exponents. So this one's top heavy. What does that tell you about an asymptote? There is none. So I like how y'all had does not exist. Guess what does not exist? The horizontal asymptote does not exist. But because it does not exist, your function can't not exist going somewhere. Where's it going? It's either going to positive or negative infinity, right? And since, so when I do this, and I want to look at it, I've got this is positive over negative, right? I'm sorry, I'm going to negative infinity. So negative infinity, if I thought about putting it in here, that would be a negative leading coefficient, right? And when I square it here, this makes it positive. So I basically have negative over negative because of those, and that makes this a positive infinity overall. Not does not exist. Okay, you with me on that? Do you understand how you have to look at the signs for those, though? Be careful with that, okay? And all that extra stuff is from my knuckles, I think, because this board is stupid. Okay. That's how I know if it's positive or negative infinity, by looking at the signs there. Any questions about that? Okay. Do you understand why it does not exist? Yes? The asymptote does not exist, but the limit does. Okay. All right, so then we look at this one here. Now, again, we're just looking at the first ones. So this right here, when I took the square root, because the bigger it gets, that one becomes more irrelevant, right? So when I take the square root of just that leading one, I get 3x squared, okay? And the denominator is x squared. So is this top heavy, bottom heavy, or tied in degree? tied in degree. And what's my limit? 3. Very good. Okay. Any questions about that at all? So yes, so the limit as we approach negative infinity. So we want to think about substituting infinity, but not really doing it, right? If I take a really big negative number and I substitute it in right here, negative cubed is negative. So that makes this term up here negative, right? Down here, this is minus 6x squared, but when I square that negative number, it becomes positive, but it stays negative because of that minus sign. So since I do not have an asymptote, at the end here, I'm either approaching, well, actually, I'm going that way. So I'm either approaching a positive or negative infinity. Like, I don't know which one, but that's what helps me. I end up with negative over negative. That's why it's positive infinity. Okay, good question. What else you got? Anything else? Okay, good deal. All right, so let's flip it over on the back. Okay, so you're going to consider the functions below in order from fastest growing to slowest growing. Polynomials, exponentials, logs, and factorials. Okay, so I want you to go back to your arguing spots. And I want you to come up with an order for that from fastest growing to slowest growing based on what you know. If you want to, you can use whatever you have to help figure it out. You can erase what's up there if you want, but I'm going to give you some time to think through this. Do you even know what a factorial is? Okay, so let's talk about what factorial means first. A factorial, and one of the reasons you don't know, I feel like it is explained to you at some math class somewhere along the way, but you probably, like, they say it and then you never see it again or something like that. It could be the end of pre-cal. We did not do it for multiple reasons, but again, it's not the end of the world. So you may have seen this before. That doesn't mean 5. Okay, it's not a happy 5. Okay, it means 5 factorial, which is 5 times 4 times 3 times 2 times 1. That's what a factorial is. Okay, so when we're talking about factorial functions, you might have like x factorial or something like that. Okay, that's what that is, so that it makes sense and you can kind of figure out where it may fit in there. Okay, we good with that? So I heard from the O means you have seen it before, you just kind of didn't remember or didn't do much with it, right? Okay, perfect. All right, so go ahead. I'm going to give you a little bit of time. So we're going to look at, I'm going to show you this Desmos thing to kind of talk through it a little bit. All right, so I'm going to start with an exponential just for you to see it. Here's an x cubed. Now my domain is really big, okay? There's x cubed. There's x to the 5th. Y'all all have exponentials first because, well, okay, you decided. Was that peer pressure or you really feel that way, whoever did that? You're like, well, everybody else has it. You don't even know what's going on. It's okay. It's okay. But we know exponentials grow really, really fast, right? I get that. Okay, so now I want you to see, and these look pretty close to each other, right? So I'm going to increase my domain more and more and more, and I want you to see what happens. The red is the x cubed. Notice how when not my domain, my range, I'm going higher and higher and higher. Look how that x cubed starts to flatten out. You know what an x cubed looks like, right? And x to the 5th looks the same, but x to the 5th actually grows a whole lot faster than x cubed does. Just didn't really look like it from what we had, right? But that's just exponential with exponential. All right, so here's the log graph, which in addition to that, which now you can't even see, I'm going to back out of that some so that you can see it, and then I'm going to go back up. But that log, see the log down here? We all knew that they grow pretty slow, right? So it wasn't up at the top of our list. I get that, okay? And I can add my zeros back there to kind of straighten it back out. And then log kind of becomes non-existent. I mean, it's not non-existent. It's just like almost flat. All right, so here's e to the x, which is also exponential, right? It just kind of goes right in there with it. And then, so I'm sorry, these are polynomial, not exponential. I don't know what I was thinking. This is your polynomial, this is your exponential. I said that backwards. Y'all understand that, right? X cubed, that's polynomial. Exponential, the variable's up there. But either way, this one's actually growing a little bit faster than this one. But in general, we'll look at what happens. Here's your factorial graph, but only part of it. It's the other parts that are weird. Here's your factorial, so it's the black one. And if I go back over here, and I keep adding zeros, Look who really takes dominance here. The factorial is, and nobody put that, but again, you don't have a great understanding of factorial. I get that. But then look at what comes next. What comes next is the exponential. It's purple. Then the polynomial, which is blue, and then the log, which is way down there, and we can't even see them. Okay? So our order is factorial. So we'll do, it's factorial, exponential, polynomial, log. And this is important to know. Okay? So I was told that somebody uses the acronym FEPL. I was actually Miss Bruce. We'll talk about Miss Bruce a little bit more. But she was like, no. And I was like, okay, whatever, FEPL. So last year I said, and it can be like, we could come up with a little saying or whatever, kind of like, Sokoto. So they decided, my class last year, and then they remembered it all year. So the weirder it is, remember, that you can remember it. They decided it was factories eat people's legs. So if you can remember factories eat people's legs, you can remember what order it's in, or remember FEPL, whatever works for you, but this order is important. And the reason the order is important is because you're trying to look at not just rational functions like the front, but when we want to look at top heavy, bottom heavy, like what grows faster. If you have a factorial over a log, the numerator grows faster, so it's top heavy. Make sense? And that helps you with what it is, if it's top heavy or bottom heavy, that type of thing. Okay? So, so let's talk about some of these examples here. Because these are things that we know, right? We know what natural log looks like, or what a log function looks like, parent function. I saw some of y'all drawing it. You at least know it's slow because that's what you put last. But basically, that's your parent function, right? So by knowing what the parent function looks like, as x approaches infinity, what does f of x approach? Very slowly. Infinity, right? There's no asymptote up there. There's a vertical one right here, and that's why we looked at this yesterday. As x approaches 0 from the right, we were approaching negative infinity. But as x approaches infinity really, really big out there, very slowly, y is going to approach infinity, so your answer is infinity with no equal sign, right? Your answer is just infinity. We don't put equals. Okay? We good? So as x approaches negative infinity, what do you think e to the x approaches? Do you know what e to the x looks like? Looks like 2 to the x or whatever. It's your exponential. Boom. Like this. Is there any, what is e? It's about 2 point something, right? Even if you don't remember, there was the 2 point some, it's 2.7 something. So it's a number. Is there any exponent I can put on that 2.7 whatever that's going to make my answer negative? No, because in an exponential function, you have a horizontal asymptote right here. So as x approaches negative infinity, what is e to the x approaching? You know this. As x gets smaller and smaller and smaller, so does y, but it's approaching what? 0. There you go. So then we can say equals 0 here. Very good. All right, then let's talk about this last one. We'll get to the rest of these. You can at least think through these before tomorrow, see if you can figure them out. Sine of x. You know what the graph looks like for sine? The answer should be yes, or you're really going to disappoint me. Okay, all right. Something like this, right? And it just keeps going. Yeah? Okay. So as x approaches infinity, what is f of x approaching? Or what is y approaching? Is it approaching anything? No, it's bouncing back and forth, right? And it's not like bouncing back and forth and getting closer and closer to 0. It's bouncing back and forth the same. Do you remember what the fancy word is for bouncing back and forth? Oscillating. So it's an oscillating graph, right? So this does not exist because it's not approaching one specific thing. Okay? So I want you to at least try to think about the rest from what we talked about up there, because that's kind of how this stuff gets applied. All right? But think about it, graph them if you want, look at them, and then we'll talk about these tomorrow. Okay? We good? What else is happening here tomorrow? Quiz. Okay.